Hello everybody. Welcome back. Alrighty. So, last time, as you may well know, possibly, potentially, maybe, possibly, let's see here. We were working on this, whatchamacallit, this tutorial over here. Bam. Hello. Oh, hold on. Let me fix this really quick. There we go. A little extra light on us. Perfect. So, we were last working on this here. I was going in circles trying to figure something out that I was actually just doing wrong. But for the most part, I get what how to do it.
Add functionality for each state. Match. Match is the Godot equivalent.
So we were moving on to the next part of this. Actually, hold on. I keep forgetting to launch my stuff over here. There we go. That's better. So, we were doing this. You just had to load up. Yeah, you can see we did a whole bunch of stuff that I, honestly don't think I needed to do. I don't even really know what I was trying to accomplish with this. Jelly, don't remember. I think I was just trying to make it to where I had a thing over here. I clicked on whichever one, and they would print out what their name is and their alignment, as well as being able to swap their alignments on the fly, so that every time I ran it with a different character, I could test each alignment and what have you. I was just doing a whole mess of stuff that I didn't really need to do. So let's just go ahead and get rid of this. And let's see what we can do from here on out.
Of this switch statement from other languages. It allows us to execute different code depending on the value of the
Move it
variable.
down.
In this case here, we can use a match statement to add some code for the different values of our enum. So I'll write match, then the variable we are matching based on, which is my alignment, colon, and now we add code for each value. So in case my alignment is alignment.ally, I'll print hello, friend. If it is neutral, I'll print I come in peace. If it is enemy, taste
nice.
my wrath. And a cool thing here is that we can actually add a default response as well. To do that, we do underscore colon.
Well, this is what I was doing earlier.
Any of the cases above, we'll print who art thou? And if we set my alignment to say enemy, taste my wrath. Modifying nodes 2.0. So far, when we need to access a node, we've done so by
I think he was
simply
doing the
dragging it
one
into
thing
our
I was
script,
trying to figure
which
out last
creates a
night.
$sign followed by the path to the node. I've created a few empty nodes here to demonstrate. A player node with a graphics and weapon node,
Whatever.
and an enemy node. So if I drag in the weapon node, it creates a path that goes into the player and finds the weapon. And we can actually store this reference in a variable. To do this, we simply drag it to the top and hold down Ctrl while releasing. This automatically creates a variable with the name of the node and the correct path. And as you can see, it uses the onReady keyword. This is because Godot has a very strict order in which nodes are created. And if we open the game and try to find the weapon node before it exists, we will get an error. OnReady simply makes sure that Godot waits until all child nodes have been created so we don't get any issues. And just a quick note, the $sign here is actually just shorthand for using the getNode function. So this is actually identical. Also, you might have noticed that the path is relative. Our script is on the main node, so it starts right after that node.
I prefer doing the
We
$sign
print
method.
the absolute path through script. We'll print weapon.getPath. This prints the absolute path starting from the root of our game all the way to weapon. Now paths are
Okay, so
great for many things. Starting from we'll print weapon.getPath.
okay, so print weapon.getPath. So say I add window So I could probably do font ready. Print HTTP request dot get path. Did I do that right? Just rename it to test. Wait. Use the okay, yeah. That's right, I had to declare here. And now root node window node 3D node 2D control test. Okay. So I can do get paths. But I need to actually have it declared in this thing right here. I have the path right there. Let's just do this again. Okay, it's just this. So the name of the variable is test, the type is HTTP request, and that's the directory for it. Got it.
This prints the absolute path starting from the root of our game all the way to weapon. Now paths are great for many things, but sometimes they can be a bit inflexible. They break if we rename any of the nodes in the path, and it's best to only use paths when the node we want to access is a child of the node we are working on. We'll talk more about parent-child relationships later. Luckily, we can also use the export keyword to reference other nodes. So if we write export and create a variable called myNode, we can set the type to node. And then in the inspector, we can assign whatever node we want, or simply click and drag. I'll drag in the player. We can also talk more about parent-child relationships later. Luckily, we can also use the export keyword to reference other nodes. So if we write export and create a variable called myNode, we can set the type to node.
Okay.
Node. And then in the inspector, we can assign whatever node we want, or simply click and drag. I'll drag in the player. We can also check if the node is a certain type by using the is keyword. So in ready, we'll check if my node is of type node 2D, in which case we'll print is 2D. And it is. We can even be specific about what type of node we want to be able to reference. If, for example, we word, so in ready, we'll check if my node is of type node 2D.
Ready. If huh? Unexpected indent in class body. What do you mean? Oh, I need to add the fucking... That's right. There you go.
In which case we'll print is 2D. And it is. We can even be specific about what type of node we want to be able to reference. If, for example, we only want to reference sprite nodes, we just change the type to sprite. So sprite 2D. I'll reset the variable here, and now we can only assign sprites, which in this case are the graphics and weapon nodes. Now if we play, it still prints.
Okay, let's change it to this. Huh.
That this node is a 2D node, even though sprite 2D and node 2D are two different nodes. This is because sprite 2D inherits from node 2D, but we'll get into that in the inheritance chapter. Signals. Signals are messages that nodes can send to each other. We use them to notify that a certain event occurred. It's probably easiest to look at an example. Godot has many built-in signals.
We'll be back
Take this
into it,
UI
baby.
button. If we select it and go to Node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double click it, I'm going to select main and hit connect. As you can see, this creates a function called onButtonPressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here. And now if we play and press the button, it prints money.
Let's go.
As you can see, this creates a function.
That's what we're here for. We're here to print money. Print. Press me. Okay. Go in here. Oof. Let's do where is it? Material layout, maybe? No. Transform? No. Theme overrides? Font sizes. Such a weird thing to put it as. Constants, colors. How do I... Face behavior, alignment, center. Okay. Is there another, wasn't there another, like, alignment thing? Oh, icon alignment. don't know, whatever. Hell yeah.
Button pressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here, and now if we play and press the button, it prints money. Get it? Now this is because whenever we press the button, it emits the pressed signal, and everything connected to it gets called. In this case, our onButtonPressed function, which indeed prints money. We can connect as many functions as we want to a signal. They will all be called when it gets emitted. This is really cool because it allows us to link together nodes in a way where they don't have to be aware of each other. The button has no idea which functions are connected to the signal. It just tells it to emit. This makes signals great for separating different parts of our game, or decoupling. Say we're playing a character that can level up by getting enough XP. Whenever we level up, there are probably many game systems that need to update. The UI, our player stats, perhaps we have spells or achievements that unlock, and updating all of these from the player can quickly become a mess. Instead, we create a leveled up signal that all these systems can connect to. Then, all we need to do is have the player emit the signal when we level up. Let's try it out. Instead of a button here, I'll create a timer. So I'll add a timer node and set it to auto start. This will count down from 1, and when it reaches 0, it...
Yay. Add a timer node. Auto start. Signals timeout. Consider the node. Do print. Timeout. And then one thing, let's make sure. Okay, no, it's not one. It's not one shot then. Okay. Let's do. How about this? For seconds equals 0. Seconds equals 1. With seconds on. Damn it. Stop doing that. Ring. There we go. Now. There we go. Perfect.
It emits a signal called timeout. Let's connect that to our script and make it increase our XP. So we'll create an XP variable, default it to 0, then in our function, we increase our XP.
Basically just exactly what we talked about.
If our XP then reaches, say, 20, we'll set it back to...
P. Yeah, sick.
To 0, we leveled up and we can start over for the new level. And if we then play, it's going to increment our XP every second, and when we reach 20, it's going to go back to 0. Now let's...
If XP 50. What the hell just happened? I said hit control slash. But hit no, I have to do shift that. And print you leveled up. Yeah. Hell yeah. Nice. That's what I wanted to do.
Let's create a signal that other nodes can connect to. So at the top we'll write signal, leveled up, and if we save this and select our main node, we can actually see that signal. We can connect it to other nodes, but just for this example, we'll connect it back to our main node. This creates an onLeveled function, which is called when the signal is emitted. Let's print a message that says ding. Now we simply have to emit the signal. Let's do that when we reach 20 XP. Here we'll write leveled up dot emit.
Fuck yes. Wait, why are you throwing me this weird error? What?
Now when we reach here we'll write leveled up dot emit. Now when
I
we
need
reach
closing
20
brackets. So
XP,
what happens if I
we
don't
get the
use
signal,
closing brackets?
and we print ding. Awesome. We can also connect signals through code.
Okay. No, I need to have this. Very nice, very nice.
I'll disconnect the signal in the editor, and instead, in a ready function, I'll write levelup.connect and the name of the function we are connecting to. On leveled up. Careful here. Here, this will probably autocomplete with parentheses. We don't need those.
Next. Oh, I know.
We just want the name of the function. And disconnecting is just as easy. Disconnect. We can also pass parameters through signals. This could be used to pass the level we reached or other useful information.
Let me actually make a new thing.
I'll just add a quick message that we can print. So on a signal, we'll add a parameter. We'll make sure that our function supports this as well. And instead of printing ding, we'll print whatever message was input. And then
message.
then when we emit the signal, we can put in a message. Let's put in grats. And
What?
and voila, it displays
Oh,
grats.
what?
And that is signals. Get, set, go. Or just
Congratulations. You have just leveled. Can I do an export? No, I can't. I had a feeling. That being said, though, I could make a variable called MSG. Just do what he was doing earlier. And now I need to export it. And now here's this SG. And now if I go back here, see, nowhere in this script does it say that other than here. So let's try this out. Probably should have set to a smaller number, but whatever. Yep. Touchdown. Let's see. Hell yeah. So that works great. Let me set up a script on this, an empty one. Create. Okay, func underscore ready. Let's just do passive right now. I'm not annoyed by the red on my screen. Okay. What was it? Control scroll wheel? Yeah, I can do that. Zoom in and out. Okay. So, next up, let's see. Connect. Yeah, I don't know how to connect. Hold on. I guess I don't really need to do that. Oh, hold on, I have an idea. HP. I know. You're getting mad at me because I'm messing stuff up. HP. 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 Do minus equals 5. And then let's just do 25. Alright. You died. Right. HP lost. It'd be current HP, wouldn't it be? Current HP. What? Oh, just fucking. We'll worry about that later. It didn't do what I wanted it to do. What was the issue? Oh, I needed. Okay, that's right. 'Cause it was up to 50, but it's going down. Actually, I'm just gonna repeat. You died infinitely. Once it hit 0. Yeah, because it's not resetting. And then it's minus 5ing. Okay, is equal to 0, HP equal to 25 again. So let's hold on, I'm trying to think about this. Would I ever have to? Okay, this is the part that confused me. I don't think I ever have to move information from this one to another one. I could just affect it in the script on this one for some reason. Like say, if I hit this character, I would need to admit that I need to subtract 5 from this one over to here. I would need to say that if it was hit, then subtract 5 on this end. So I think that's where my issue is coming in. If you know what I'm talking about, I could be sounding like a crazy person right now. I'm totally aware of that, but yeah. Okay, right to this.
Get set. Getters and setters allow us to add code for when a variable is changed. This means that we can do things like clamp a value within a certain range, or emit a signal letting other parts of our code know that the variable changed. The example that is always used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to. And now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp it first between 0, and 100. So this makes sure that our health does never exceed 100 or go below 0. We could also emit a signal here, so we can create a signal, health changed, and we can actually input the new health as a parameter. And then in our setter, we can go health changed dot emit and put in the new health. Of course, we need to make sure to connect this signal. We can do that through the editor, and let's just print the value. So we'll print the new health. Then in ready, let's try this out by assigning a value to health. Let's try assigning negative 150. And now if we play, we can see that it prints 0. This is because we put in negative 150. It clamps this to 0, and then it emits the signal. The signal then calls the onHealthChanged function, and we print the new health, which is 0. So that's a good example of adding a setter. Getters are more commonly used to convert values. So let's add two variables. We'll have a chance that is equal to 0.2. And then we can have another one, which is our chance in percent. We'll make this of type int, and we will add a getter. Here, whenever we try to get the chance percentage, we'll simply return the chance variable times 100. And now if we try to print this variable, print chance percentage, or change our chance to, let's say, 0.6 and print it again, we can see that our chance percentage is completely based on whatever our chance is currently equal to. And so it starts at 20% and then goes to 60%. And for good measure's sake, we'll add a setter also. So if we set to a new value, we will modify our chance and set it equal to the new value divided by 100. And since our chance is a float, we'll make sure to cast that value.
All right, let me rewind a bit. Let's see what he's doing here.
Then calls the onHealthChanged. Then in our set,
Let's try this.
Setter in the is always used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to. And now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp it first between 0 and 100. So this makes sure that our health does never exceed 100 or go below 0. We could also emit a signal here, so we can create a signal, health changed, and we can actually input the new health as a parameter. And then in our setter, we can go health changed dot emit and
Hold your fucking horses, good lord. Health change. What the fuck? Where did value come from?
What to do. So this is find a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to. And now we can decide what to do. Emit a signal, and we can actually input this signal. We can do that through the editor.
Oh, it's Sentinel, not Signal. There we go. We do this instead.
And let's just print the value. So we'll print the new health. Then in ready, let's try this out by assigning a value to health. Let's try assigning negative 150. And now if we play, we can see that to health.
Health. 100. Let's see if we can make heads or tails of this. Okay, so health is 100. Let me see. I can't click on set of all things. Are you fucking serious? Yeah. $100. What the value is between these two numbers. Health change dot emit health. New health. Okay, so this just, so if I do this, I'll do 50. If I do negative 27, I'll do 0 again. Okay, but if I remove this entirely for a pass function, this should just set it to 100, right? Only if it gets changed. Got it. Okay. Hey, listen, I'll explain it one more time. I'm still hazy on how this works.
Code it, set, go, or just get set. Getters and setters allow us to add code for when a variable is changed. This means that we can do things like clamp a value within a certain range, or emit a signal letting other parts of our code know that the variable changed. The example that is always used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to. And now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp it first between. Always used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to. And now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp.
So let's say, hypothetically, for words, right? Hello, long. Then I set this to changer, for instance. And now health, no, words equal power. I mean, let's do Word change, not omit. Alright, let's null. You might, I need omit. On word changed. Uh, print. I do an export of this. Yeah. Nothing. Okay, so let's say I change this via the via this. Goodbye. Alright, now I do this. It does not change. Okay. So in that case, let me do var words equal to goodbye. What the fuck did you just break, motherfucker? Oh, I know. Somebody's cooking up something good. Smell meat and onion. I think we're making spaghetti tonight. Hot dog. Okay, let's try this. No. Okay, so that doesn't mean anything. What the fuck? Okay, hold on. 12 equal 150. Why did that print? Okay. Oh, hold on. That explains it. Well, work? Question mark? Nope. Does not work at all. Fuck. Okay. Hold on. Where are we getting new house from? Hold on. New. Okay, let's do new word. Okay. All right. So we're gonna do new word and then new word. What the fuck? Okay. Okay. So let's do this one step at a time. Health change, new health. All right. So set. All right, all right. Where's the value at in this? Value's only used there. Okay. Let's just do words equal to. Hold on, right? How does I do this? Nothing. Absolutely nothing. Hold on, let me just print. It's not it's not declared in the scope. Yeah, so I can't even do that. Okay. What the fuck? Okay. I'm gonna need a fuck off. So it's actually activating this, right? But the actual word change dot emit is not actually getting. Wait a second. What about now? No, it's not. Fucking hell. Okay. New word. Huh? Okay, that probably actually is gonna fix some stuff. Oh, sick. It actually just connected it. Hold on a second. Oh my gosh, I fucking did it. I literally just forgot to connect the signal. Oh, fuck yes. All right. I don't think I need this part. Yeah, I don't need that part. So the emit. Uh. So if this gets changed, it changes this to the new value, which is submitted, which emits to the word changed function, which is printed here. Okay. I think I got it. It's like weird analogy, but think of it like a trap chest in Minecraft. Like the moment you open it up, it sends out a signal. Uh that's one way of looking at it. Actually, if I change this to buy and then it changes to buy anyways, that should. Okay, no. So let's say Okay, let's get rid of that. Get rid of this, right? Okay, nothing's here. Hello, hello. And then if I do words, oh no, I just need to do words. Then this should be the, okay, so I think encode what's happening here, even though it didn't actually change what it says, it detected that it was updated in some way. Not necessarily that it was replaced, it just got replaced by itself. So that's the reason it's going back and saying, hey, something updated. This is what it now says. I think that's what it's doing. Do I know for a fact? No. But it's my best guess. So that's interesting. It's a bit better. I'm glad I have the ability to just experiment with this stuff and quite literally fuck around and find out until it works, you know? So, okay. Good. Come on. Where? There you are. Perfect.
But first, between this signal, print to 0, and then it emits the signal. The signal then calls the onHealth changed function, and we print the new health, which is 0. So that's a good example of adding a setter. Getters are more commonly used to convert values. So let's add two variables. We'll have a chance that is equal to 0.2, and then we can have another one, which is our chance in percent.
Okay,
We'll make this of type int.
Pause. Open this up. Fuck you. I don't know why it does that, where I'm trying to tab it over to it, but it's just, I know why, because I clicked on a window in between the two, but damn, it's annoying. Variable, come on now, chance equals, car, Carl, equal to 0.2, stop, Butterfingers,
and we will add a getter. Here, whenever we try to get the chance percentage, we'll simply return the chance variable times 100.
Equal to integer. Oh wait, no, that's wrong. Get return. Fucking hell.
And now if we try to print this variable, print chance percentage, or change our chance to, let's say, 0.6.
What's the difference between this and just changing the variable? I could just set this to chances equal to, well, I don't know. I could just say change percentage equal chance times 100, right? So why is this like this?
And print it.
Okay, let's see. This is a complicated question, so I'm gonna have to ask this. In GD, let's say that I do one called chance and the other chance. percentage. I am using a to um set the out of percentage is as so. Okay. Paste. Oh, fucking hell. Yeah. Why would I use a getter instead of just saying something? Uh, equal to. Fuck, what the hell is wrong with me? Why can I not fucking type today? Chance times 100. Key difference. Let's fucking go. Only once time you read it. Automatically, no. Okay, so getters are updated automatically while just having a variable like that is not. I assume. Let's go on real world reasoning games. Change percentage to always. Chance percentage to always. Especially when chance during the game. Using tooltips, debug display. Flash load the value, you print it for debugging. Plus when the plain variable breaks. Okay. So that's 25 right now. Okay. Ready, label.text, string, chance shows 29%. Sounds good. Player buys an upgrade. Chance is plus equal to 0.10. Now it's 0.30. But the label is still showing 25%. Okay. So that's okay. So my assumption is that's further, since this updates further down the line, then hypothetically, if let me just do this real quick. Ignore anything that turns red when I do this. That works out. This is down here. This doesn't know this just happened because this is so far down this. Okay. Let me actually do a label so I can actually do this properly. Okay. 8. So let me go to 2D here. Label. Text. Let's see here. Theme override, font size. Shit. What? Invalid assignment of property to key. Uh, of property or key text by type of string. What the fuck do you mean? Base object type null instance. Excuse me? Let me do this real quick. You know what? Hold on a second. I think I know what's going on. I think I might need to actually put it in here because this I need to actually just remove the script from that. Okay, now let's try this. Yeah, okay, I'm seeing it now. First, a couple things. First of all, let's get you shrinking down a bit, darling. Why the fuck can I not move you? Oh, because your text is so big. Hold on. There we go. Actually, let's do alignment center, vertical alignment center. If I do this, shit. Okay, but yeah, you get the point. The text didn't update past 25%. Not kidding. There you go. So yeah, even though it should say 35% now, it is not saying that because yeah. So if I just do this instead, there we go. Text. Okay. Okay. Yeah, that makes sense. So I'm actually curious. Uh I'll just assume round I. Can I do this here? The round's the integer. I was hoping there was something like this in the code. Let me look at it. Yep, 21%. Okay, sick. And this should be 35%. Okay, that's sick. That's pretty sick. I'm happy it explained that to me because I had no fucking idea what was going on with that or why I would need it for that. Um, okay. Let's do an explanation getters. Explain to me getters. Let me put some music back on for you guys. 1 second. There we go. Very useful. They lets you turn a normal looking variable into uses it. Instead of a plain box where you can just put mail in or take mail out, getter. So it asks for mail, what they usually receive. Okay. And setter. Did I do getters earlier? Let's just do setter. When someone tries to put mail, I can check please slash reject slash first. Okay. That's useful then. Player health equals 50. Let me refresh this because I accidentally used fucking set the word getter instead of setter when asking this. Row. Okay. That's significantly longer than the last one, but alright. To be fair, it seems a bit more complicated. Getters, setters are basically their opposite, but they are even more powerful and more commonly used in real games. Okay. Okay. Every time someone reads, it is calculated fresh. A setter runs every time someone tries to write a value to the variable. A lot of reasons. Keep internal state consistent was an important reason. Clamp, sanitize, validate incoming values, trigger side effects. UI, play sound, recalculate something else, etc. Convert. So like if a value changes, it could play a sound. It could trigger a sound. Like how I was using signals to print out the change. I can use signals to play sound instead. Convert slash remat the value before storing it. Okay. Debug. Print slash log every. Print slash log every time someone changes this value. Okay. Health float 100. Right. Get return health. Set value. Health claim F value 0.00. Max health. Side effects, update health bar if health is greater than 0, die. And enough. Okay, so this is just the setup. Let's take a look at it because it's doing it in multiple parts. Let's just see what this is doing. Right. I won't do this part just yet. Max health, which is 100. Your health to minus 50 becomes 0, triggers death. So this is oh, hold on a second. Let me and I volume linear times 100. Linear. So whatever's inputted into this or whatever's changed, it takes the number here. Say 0.5, puts it in here, or whatever it is, clamps it between value, which is the what is it changed to. Well, whatever it's changed to is put here. Whatever it's set at, it's put in here, right? Divided by 100. So let's say it's 0.5. That'd be 0.05, I think. Or 0.005. So it's clamped between these two values. Yeah, this is using weird terminology for weird stuff I haven't touched yet. Chance is clamp value. Okay, so let's just do this. So where is my stuff? Here. Let's look at this. 8, 9, 1. Okay, I'll say. One, 2, 3, 4, 5, 6, 7, 8, 9. So probably around here. A couple of things. First of all, let's do set value. Okay, let's do why does it not want to do this? Yeah, I can't do that, I guess. Chance. Fuck. Wait, on. Let's do the ready. Get the function. Prince. Wait, no. Underscore chance to. Let's just say 200. Now, Prince. That's percentage. So 0.5. That'd be 50%, right? Okay, yeah. So let's say. But it's not limiting me. Did I do this? Oh my gosh. It was not happy with me there. But it's not limiting it for some reason. Value. Uh thought it needed to that's gonna be 500, right? Yeah. But it's not dividing by 100 here. See, if I put this in, say, change it to 5, this would be divided by 100, but that's not 500. That'd be 0.5. What's getting multiplied? Why are things getting multiplied? I don't understand. What's happening now? Wait, why would I do a multiplier? Same thing. It's acting like it. Whatever symbol I don't do, whatever I do here doesn't matter. Yeah. What the fuck? This is automatic returning, but why? Because it's doing it here. That's why. Chance. Let's keep looking so we can get this figured out. I think I have an idea of how it works, but these samples aren't working really. Gonna throw me some errors. Max health. Go to 100. Hold on. Well, let's just do this first. Fuck. Die. This should be declared as current scope, I believe, right? You take characters for indentation instead of spaces as used before. Oh, fuck you. Oh, I'm fixing this. Oh yeah. France. Die. Dead. There we go. Let's just say fuck. No. Let's just do return health. Or no, print. Oh, no, I didn't mean to do a variable. Fuck. Type that in. Okay. Ready. Oh wait. Fuck. Ready. Health equals 1,000. Okay, so that actually worked. Yep, okay. Should be 0. Yep. And 1. That'll be 0. Perfect. 0.1. Okay. Why do I do this? I'm a target. Okay. Let me do no, that doesn't work. That's just not doing anything really. Got it. New health. New health. New health. Perfect. Got it. So it is the 0.4. Would be 0 to the 0.5. It should run up, I believe. Yep, 1. Sick. 6.9 will be 7. And 25.2 will be just be 35. Hell yeah. Okay. So I get it now. I get it a lot better than I was before. Oh, goodness gracious. Okay. So let's not do anything, right? Let's just do pass. Nothing's gonna print, right? Yeah. Well, equal to. Yeah. So. Yeah. That's what I was thinking. Go try and break because I forced it to be do I remove this? Yeah, the error goes away. There we go. Very nice, very nice. So essentially what you can do is just make it to where it's forced to set it between this and utilize, say, okay, so you get, well, you run whatever the new number is, right? Or no, right? Yeah. Say the setter updates, right? Value is just whatever income value changes to this, right? Health is now, say, health equal to 25, right? So 0.3 for the fuck of it. So that 25.3 is going to become the go into here. 25.3 will be clamped between the 0.0 and the max health, which is 100. So there's no need for clamping really, because it's 25.3. It's between those two values, right? And then that means health is now 25.3 after the clamping is done. New health is set to the 25.3, which is the rounded rounding it to an integer. Not rounding an integer because it's a float. It's rounding it to an integer. Got it. We just did pass on the variable new health. New health is that goes into the update health bar function. Actually, let me do this. Actually, if I do a test on both of these, right? So, because I don't need to pass the same name. That's right. Because this is just filler. This doesn't exist. I could type, if I have a variable for it, it can go in there, right? So new health gets passed there, 25.3. It pushes this into this, so it's gonna print 25 because it rounded it. Yep, perfect. Also, the health is less than or equal to 0. It says die, it just says dead. See, dead. Also it prints the updated, so it's gonna print 0 and then dead because both this and this got updated. This is omitted since this got updated at all. So I think I have an understanding of what setters and getters do now. So it's basically, if value changes, do this. I can remove all this. Hold on, let me do something real quick. Value. I wonder. Perfect. Yeah, it's literally just an if statement, pretty much. It literally just acts as if value gets changed. Right. Right. If I do a pass here, nothing happens. Okay. That's so much better to know now. Holy moly. So, yeah. Okay. So if I were to say something like, instead of variable mana, right, is equal to 25, and I update that instead, nothing's gonna happen, right? Mana equals 20. And I'm also gonna do print mana too. Yeah, all you just print is that. There's no hello or anything. So that's how that works. It's literally just setter just says if value above changes, do this. I was looking for that earlier when I was testing this, when I was maybe a couple weeks ago, when I was trying to figure out some stuff to do so I could detect if a value gets changed. And I tried looking it up, saw setters and getters, did not understand what the hell any of that was about because it told me the most confusing way possible, but now I get it. Now I understand.
Hit again. we can see that our chance percentage is completely based on whatever our chance is currently equal to. And so it starts at 20% and then goes to 60%. And for good measure's sake, we'll add a setter also. So if we set to a new value, we will modify our chance and set it equal to the new value divided by 100. And since our chance is a float, we'll make sure to cast that value. So now instead of changing the chance, we can directly change the change percentage to say 40. There we go. Classes. This is a good one. GDScript is an object-oriented programming language. This means that we generally try to structure our code inside of contained objects that interact with each other. We primarily do this using classes.
Sorry.
For now, try to think of a class as a blueprint. Say, for example, we are making an RPG and we need to populate it with a bunch of characters that the player can interact with. So we create a character class that has some variables and logic that all characters in the game should have. So for variables, we could add things like name, health, and a line of dialogue for when you interact with them. For logic, we could add functions like talk and die. Then we take this class and create instances. Instances are specific versions of the class. So we could create an instance named Potion Seller that has a health of 50 and a line that says, "You can handle my strongest potions." And a bunch more instances, all of which have the same variables but different values, and all of which can talk, "I used to be an adventurer like you," and die. So that's the idea of classes. In Godot, you've actually already encountered a bunch of classes. That's because all the built-in nodes in Godot are classes, which actually makes a lot of sense if you think about it. All the nodes are self-contained objects with a bunch of variables and logic that we can create instances of. If we add a sprite node, we're instancing the sprite class. So when we create a script, we are actually also creating a class. I have to put a disclaimer here that we are technically not creating a class, but for all intents and purposes, it works just like one. So let's forget all about that for now. So let's abandon our main script here for now and instead create a new node. So search for node and let's name this node character and add a script to it. Now to make it more clear that our script is a class that defines a character, let's set the class name to character. So right at the top here, we'll go class name character with a capital C. And we can now add some variables. We'll mark these with export so that we can set them in the inspector for each character instance. So export var. Let's add a profession of type string and give each character a health as well of type integer. And so now we can see that our character here has these two properties in the inspector, and we can go ahead and fill out the profession. This is going to be the potion seller, who is going to have a health of, let's say, 40. And now we can create more instances by duplicating this node. So let's duplicate it a few times. The second character here will name X Adventurer with a health of 30. And the last character will be our knight, and we'll give him a health.
Probably should have done this with the root node, honestly. This. If I add a new node, then I give it a thing. We go ahead and do blank. Good. There we go. Let's spell profession right. Let's see. Did not. Oh, I looked wrong. Profession. So how much money they have on them is another integer. That's no. What the fuck is abstract? I mean, programming. There shouldn't be abstracts that exist. Okay, so
Health of say 150. So now we have these three instances with different properties, and we can also give them a function. So let's add a die function. So write func die, and this function is going to set our health to 0, as well as print our profession and the fact that we died. And that's it for our character.
go.
Class, but currently nothing is triggering this function. So let's go into our main script now, and here we can get a reference to one of our characters and call the die function. We could simply drag and drop one of these nodes to get a reference, but because we have named our class, we can actually use an export.
What?
Export so that we can set them in the add a script to it. Now, to make it more clear that our script is a class that defines a character, let's set the class name to character. So right at the top here, we'll go class name, character with a capital C. And we can now add some variables. We'll mark these with export so that we can set them in the inspector for each character instance. So export var. Let's add a profession of type string, and give each character a health as well of type integer. And so now we can see that our character here has these two properties in the inspector, and we can go ahead and fill out the profession. This is going to be the potion seller, who is going to
Nice. Priest and
have a health of, let's say, 40. And now we can create more instances by duplicating this node. So let's duplicate it a few times. The second character here will name X Adventurer with a health of 30. And the last character will be our knight, and we'll give him a health of, say, 150. So now we have these three instances with different properties, and we can also give them a function. So let's add a die function. So write func die, and this function is going to set our health to 0, as well as print our profession and the fact that we died. And that's it for our character class, but currently nothing is triggering this function. So let's go into our main script now, and here we can get a reference to one of our characters and call the die function. we could simply drag and drop one of these nodes to get a
Okay, let me just do this. Okay. Um, uh,
reference, but because we have named our class, we can actually use an export variable for this instead. This way we can set the connection in the editor and we don't have to worry about the path changing. So we'll write export var, and here we'll have a character to kill of type character. And now if we save that, we can see that our main node now has a slot here for the
what? There we go.
character to kill. And we can either drag in one of these characters or hit assign. Or we can actually use an export variable for this instead. This way we can set the connection in the editor and we don't have to worry about the path changing. So we'll write export var, and here we'll have a character to kill of type character. And now if we save that, we can see that our main node now has a slot here for the character to kill. We can either
This is not working anymore. What? Remote? What the fuck does remote mean? I mean, the script is right. Hold on, no, hold on. Go back through the comment section, see what I can do here.
either drag in one of these characters or hit assign.
Oh, there it goes. What the fuck? I guess maybe I just needed to redo this. Because it wasn't registered as a thing yet. Okay.
And select one. I'm gonna choose character 3. And now in our ready method, we simply
Yeah, plug. Ready.
go to our character to kill and call the die function. And if we run this, indeed, and call the...
There we go. Hot dog. Well, that's simple. Huh.
Die function. And if we run this, indeed,
so let me look at this. Okay. So this one's simpler to understand, I think. The variable character to kill is just equivalent to a character node or character class. So when I do ready, I do character class dot die, which is the function within the character class. How that extends across everyone is I have no idea. It's pretty crazy, but
the die function is called on our character 3, which is our knight. So it says knight died. And if we choose another character, say the first one,
what? Hot damn.
We are instead killing the potion seller. Really cool. Inner classes.
Alright, well, that's it for me tonight, guys. That was great. And I'm learning so much. I'm progressing so much. Holy shit. This has been fantastic. I'm slowly understanding things now. After all this time. I'll be honest, this guy's video has been very important to me. I've been, so without focus, basically, I'm just kind of winging it until something clicked. And I feel like his stuff has actually really helped me out a lot. Especially when I can just get in and actually test it out myself, right? I should run more experiments with the stuff I learned today as well, but I'll save that for another time. For now, though, that's it for me. All right, everybody. Thank you again all so much for watching. And have a good night. I hope you have a good one. Bye, everybody. Bye-bye. Bye-bye.